Experiments are conducted to investigate the photoelectric effect. It is found that on exposure of a metal surface to light, either electrons are emitted immediately or they are not emitted at all. Suggests why observation does not support the wave theory of light. Any comment? Wave theory of light is just like you boiling water, right? You supply energy to the water. It takes time for the water to go to boiling point. It doesn't go to boiling point straight away. That's the idea of wave theory. It takes time. For wave, electron can collect energy, right? You receive energy continuously. Electron will be emitted at all frequency after sufficient long delay. But we find this is not true. Okay with that? It collect energy, like it heats up. Then when it has collect enough energy, then it will be emitted. So no matter what frequency it is, it will collect energy like water boiling. You heat it up, it takes some time for it to boil. So when it boil, then the water becomes steam. That's the idea of wave theory. Okay,
Yeah.
data for wavelength. Right? That's your wavelength, first column. Of radiation incident on metal surface and the maximum kinetic energy of the emitted electron are shown in figure 7.1. There's one not given. Without any calculation suggests why no value is given for EK for radiation of wavelength 650 nanometer. Can
Mm, why? Is it because it's a visible light?
wavelength is too long,
Oh yeah, too long.
too
Oh yeah,
long,
too long. Yeah.
right? That is your calculation for wavelength. Right? Wavelength is longer than threshold wavelength, so no emission. Right? There's a threshold wavelength, so it's longer than threshold wavelength, no emission. No? Use your data to determine the work function, energy of the surface. How are we going to do that? Same, no? Use this equation to find the energy of this wavelength. And then kinetic energy is given. So use Einstein's photoelectric equation. No? That equation. Right? That's a work function. That's your maximum kinetic energy. So that's your H, Planck constant, speed of light. This one changing to SI unit as a work function. That's a kinetic energy. Okay. Anything not clear?
Okay. So what does phi represent?
Work function, work function.
Oh, what
This is work
function? Okay,
function.
okay.
This is a symbol for work function.
Oh yeah.
I use small letter lah, but the Greek capital letter, there's a line at the top and at the bottom there lah. Any more question?
That's all.
Radiation of wavelength 240 gives rise to maximum photoelectric current. The intensity of the radiation is maintained. Right? Intensity is constant, maintained constant, and the wavelength is now reduced. state and explain the effect of this change on maximum kinetic energy of the photoelectron. Yep.
Increase.
State. You only state only. You haven't explained. So you are asked to calculate. Use this formula. So use this formula to explain. No?
It increases, right? Because inversely
Wavelength.
proportional.
Right? You are told that wavelength is now reduced. Smaller wavelength, greater energy. So you use that equation. No? Right? Greater wavelength, greater energy. Both functions still the same. So this one increases. So correct. Increase correct, but I got 1 mark only out of 2 mark. As wavelength decreases, photon energy is larger from here. From here. Would emit electron of larger maximum kinetic energy. How about the maximum photo current? Yep.
Remains.
Say again.
Wait.
Right? We think of intensity differently now. Right? Number of photon per second falling on the area and then energy of the photon. So intensity is constant. Right? Intensity is constant, current is also constant now. Intensity tells us
No,
the
no
number of
changes.
particles per second hitting the surface. So if that is constant, the current is constant now.
Oh, okay.
Oh, sorry. Fewer photons per maximum photoelect. Sorry, you are reducing the wavelength. So reducing the wavelength, you are increasing the energy. So you are increasing the intensity. Even sorry, your intensity is constant. You are increasing the energy of the photon. So the number of photon per second falling on the surface will increase. So what am I doing? Intensity is constant. HF increases. So NT must decrease. So that's why I say fewer photon per unit time falling on the surface. So maximum current is smaller. No? Right? The current measures a photon meeting an electron. So if the number of photon hitting the surface is lower, so the maximum current is also smaller. No? Can
Mm.
more photon, more electron emitted, more current. Less photon, less current emitted, less less electron emitted, so less current. Also. Can
Okay.
intensity is constant when wavelength decreases, F increases, and T is smaller. That's what this is saying. Okay? An explanation of photoelectric effect includes the term photon energy and work function energy. Explain what is meant by photon. This one all memory work you must score.
Single light particle.
Say again.
It's like a single light particle.
No. Even though it's called particle, it's packet. or quantum of energy of electromagnetic radiation. Work function energy,
The minimum energy required to remove an electron from the surface.
minimum energy to cause emission of electron from the surface of metal. Okay. In the experiment to investigate the photoelectric effect, a student measures wavelength of the incident light on the metal surface and the maximum kinetic energy of the emitted electron. That's maximum kinetic energy is 1 over lambda. A variation of E max of 1 over lambda is shown in figure. Work function energy of the metal surface is, right? It's a symbol phi. State an equation in terms of lambda phi ek E max to represent conservation energy for the photoelectric effect. Explain any other symbol you use. Okay, how do you write the equation? What equation? Memorize this equation, no? Hc, Einstein's photoelectric equation, Hc over lambda equals to Ek max. We call it E max. So we call it E max also rather than Ek max. And then find the work function. Then you have to define what is C, what is H. Right? These are the terms given, so you don't need to define anymore. Where C is speed of light, H is Planck's constant. Okay?
Yeah.
Yeah, I asked you to state the equation. Then after that, you want to use the equation. Rewrite the equation. Use your answer in 1 and figure 7 to determine the work function of the metal surface. How to determine that? Yep. That's the graph. How to determine the work function.
Mm. Uh,
Play with the equation. Rewrite the equation in the form of 1 over lambda. Then Ek max. That's the equation. Rewrite it. Right? You want it in this form. 1 over lambda. And reproduce it. You can find gradient, but that's not what we want yet. You can find gradient and reproduce it backwards. Find the x-intercept, and then you can use a big triangle to find the gradient. You can find the gradient, but that doesn't help you. You want to find work function. So how are you going to do that? Right? When 1 over lambda equals to 0, right? That is equal to 0. E max equals to work function. Yeah, so we have to read the graph, that's all. Read this point, which is about 4 or 3.9 there. Right? Times 10 to the power minus 19. Remember that? Okay with that? They allow you a mistake of half a square, half of the smallest square.
okay.
Value of Planck's constant, right? Gradient, no? Right? That is the equation. And you can find the gradient. This you divide by HC, divide by HC. So 1 over HC is a gradient. Right? Rewrite the equation. Divide by HC, they get the equation there. So the gradient you can find from the graph. And gradient is 1 over HC, that's a gradient. So cross multiply, take H across, gradient down, gradient times C. Right? That's why we found gradient. That's the speed of light. Then we get it. First, you must show that the gradient equals 1 over C, 1 mark there. Then your gradient, any value between here, 1 mark. That H is 1 over gradient. That's your step there. Right? The step there must be there. And then your final answer, altogether 4 marks. Okay. Any
Yeah.
comment?
No.
Explain why for photoelectric effect, the existence of threshold frequency and very short emission time provide evidence for particulate nature of electromagnetic radiation as opposed to wave theory. Can
I don't understand the question. Uh,
you have threshold, you say explain why for photoelectric effect, the existence of threshold frequency and very short emission time provide evidence for particulate nature of electromagnetic radiation. That means we think of electromagnetic radiation as particle because of threshold frequency and short emission time. Whereas wave theory will, right? Remember the wave coming in, you give energy to the electron, then energy, we both are very small, so it will receive energy. It's just like boiling water. You, you want to boil water, you receive energy. Receive until enough energy, then the water will boil. So the same thing, the electron will receive the wave energy, receive until sufficient energy, then it will escape. So there is no short emission time. It's a long emission time. Wave theory predict at any frequency would give rise to emission of electron if exposure time is sufficiently long, which is not true. Photon has specific value of energy dependent on frequency. Right? That's why we now explain threshold frequency. Emission of electron occur if energy of photon is greater than work function of the surface. That means there's no time lag or short emission time. Can
photon has a specific
excuse me,
value.
don't know
Ah,
why
okay.
I'm sneezing all the time. Okay, anything not clear?
Yeah. Okay.
State and explain two relation in which Planck's constant H is a constant of proportionality. You should be able to state one of them. The other one we haven't learned yet. I think we leave it for you. Okay,
This one is state the two formulas one, is it?
because I teach you only one formula. Now I'll teach you the second formula. Lor. So hopefully you can answer after that. Lor.
Oh, the E equals HF, one of it.
E equals HF is one of them. Lor. You got it
Okay.
right. Lor. Anyway, we'll go over that in a while. Lor. Teach you the second formula. Lor. Okay, can see the picture? Can see the slide? Can or not?
Yes.
Okay. Wave particle duality. Right? Cartoon just basically show you they both of them have to live with it. Lor. Right? Page 231. Right? We are covering understanding the right. All these are we have will cover. Lor. The de Broglie hypothesis, formulated in 1926, predict the particle should also behave as a wave. De Broglie's formula was confirmed 3 years later for electron, which have a rest mass, with the observation of electron diffraction in 2 independent experiments. At the University of Aberdeen, George Baker Thomson passed a beam of electron to a thin metal film and observed predicted interference pattern. At Bell Lab, Vinton Joseph Davison and Lester Hubbard Gomer guide their beam to a crystalline grid. Thomson and Davison shared a Nobel Prize for Physics in 1937 for their work. Basically, we have hypothesis first. Hypothesis will tell us what can we expect. Right? That electron can behave as electron, which is particle, can behave as wave. So experiment is a bit usually will take time to confirm lah, because experiment require sophisticated instrument. So that's why hypothesis come first, theory come first, then experiment to confirm it. And these two person, Thomson and Davison, is the one who confirm it. That electron can behave as particle. Sorry, electron can behave as wave, not any particle. Due nature of light. The idea of light being a wave motion and the idea of light being a particle motion are merely two different models which help us explain the behavior of light. Neither is necessarily a literal description of what is light. Duality having two different natures. Properties of particle are mass. Right? That is particle, it has mass. It has size, how big, how small. It has kinetic energy and momentum. Photoelectric effect, appearance of line spectra, which we will study today, and the production of X-ray shows a particle nature of electromagnetic radiation. Properties of wave are frequency, wavelength, and amplitude. Interference, diffraction, and formation of standing waves show the wave nature of electromagnetic radiation. Right? There's a particle, there's a wave, right? Wave of frequency or wavelength, amplitude. Physicists have come to terms with the dual nature of light. Right? Have come to terms with light can be having two nature, wave and particle. This duality is referred to as wave-particle duality of light. Light interacts with matter as particle, the photon. Light travel through space as wave. Right? Light travel, electromagnetic radiation, it travels through space as wave. But when it reaches the matter, it will interact with matter as a particle. So de Broglie hypothesis or equation, imagine that electron would travel through space as wave but interact with matter as particle. De Broglie's relation gives the relationship between wavelength and momentum of a moving particle. That means basically it gives you the wavelength of a moving particle, given by P equals to H over lambda. You're required to recall and use H is Planck constant. Right? Equation gives the wavelength of a particle. Right? So that basically de Broglie's equation. The wavelength gives the equation. The equation gives the wavelength of a moving particle. Okay, just to review our diffraction of light through aperture, circular aperture. Right? Don't worry about the formula. Greater wavelength, greater diffraction. Or diffraction also can be lah. Right? Greater wavelength with greater diffraction. Or diameter of the bright spot increases. Okay? That's the bright spot. The red one is a dark spot there. So that is the ring you will see lah, for diffraction to occur. Electron can be shown to behave as wave. Right? There is a setup. This low powers hitting the cathode. Right? There's the cathode hit by a low power source. This is an electron diffraction tube. Electron diffraction tube. The cathode heated up will give out a beam of electron. We got 10 more minutes. Electron. And then there's a carbon film. Right? The reason why we use carbon film is because the electron will have a wavelength, and the wavelength is roughly near the intermolecular distance or size of the intermolecular distance. That's why we use carbon film. Right? Anode, the electron emitted is accelerated by the anode. Fluorescent screen allows us to observe the image of the electron on the screen. Right? There's the angle theta. That's straight through. This line is straight through. That's the angle theta. Electron gun produce a beam of electron. They are accelerated by high potential. Right? 5 kilovolt. Accelerate the electron. Right? We can change that voltage there. The accelerating voltage. Change the voltage V. The energy and thus the electron speed of electron can be changed. So we change that. We change the speed and energy of the electron that is being accelerated. And that's why we observe. Observation. Beam strikes a carbon target and diffraction pattern appears on the screen. Right? How do you see? Pattern of concentric ring observed on the screen. Right? That's the surface of the CRO. Right? That's the ring that we observe. Pattern similar to diffraction pattern observed with visible light. Wavelength decreases. Right? Wavelength decreases. Circle become smaller because the diffraction is smaller. Increasing the anode cathode voltage makes the pattern shrink. Why does it mean? Well, we are increasing this voltage. We are increasing the energy of the electron or velocity of the electron. The electron has more kinetic energy. They are thus faster or greater momentum, the shrinking of pattern shows that their wavelength has decreases. Right? More energy, more momentum, smaller wavelength, right? More momentum, smaller wavelength, H is constant. Wavelength, don't worry about the formula, just in giving you for info only. This is the spacing of atomic layer. Speed of electron equals to work done equals to gain in kinetic energy. This is a formula you need to memorize. Right? That is the accelerating voltage. There's a charge on the electron. This is the kinetic energy of the electron. Okay. Any comment? Any question?
No.
Okay.
Okay.
Probing matter. High speed electron for particle accelerators have been used to determine the diameter of atomic nuclei. High speed, the wavelength is going to be smaller. This is possible because the high speed electron have wavelength of the order of 10 to the power minus 15 meter. This wavelength is similar to the size of the atomic nuclei. Okay, this is for your info. How we find the diameter of the nucleus. Ordinary moving bodies have very short wavelength. Thus, the wave nature are not shown by them. Right? We'll see in the example. Okay, calculate using this formula and comment. What is the Brody wavelength for a bullet of mass 30 gram and moving with a speed of 320 meters per second? Okay, calculate and then comment. Right? Momentum is mass times velocity. Change it to kilogram times velocity or speed. 5.6 Newton second. So there's a P, momentum. There's a Planck's constant or lambda. Okay, now you can see it's very, very small. You cannot even make a aperture that small. So how can the bullet will go through? Bullet has a bigger size than that. Wavelength of bullet is very small. That wavelength of bullet is very small. That it is not possible to make a slit that's this small. Besides, the bullet is unlikely to be able to pass through. Right? Bullet is so big, the aperture is so small. So bullet cannot pass through. Okay?
Okay.
That's why we cannot observe the diffraction pattern, the wave nature of bullet. Okay, so for this topic, summarize for you. Right? De Broglie's equation gives the wavelength of a particle with momentum p, or moving particle. Duality having two different nature. Thomson passed a beam of electron through a thin metal foil and observed the electron were diffracted to form a pattern of ring. Okay, during the 15-minute break, you can try the question. After that, we will go to energy absorption and emission spectra. Okay, we have done that just now. Now you should be able to explain this one. State two relation in which Planck's constant H is a constant of proportionality. Yep.
The Broglie, yeah, lambda equals to H over P.
You have to explain the formula. Photon is a packet of energy of electromagnetic direction. The photon energy h times frequency. Every particle has an associated wavelength. Wavelength equals to h over p. Where p is the momentum of a particle. Right? You cannot just give formula. You have to explain the formula. What does the formula stands for? Okay, basically these two formula. Okay. Any comment?
Nope.
State what is meant by the Brody wavelength. Yep. Wavelength of wave associated with a particle that's moving. Electron is accelerated in vacuum from rest to a potential of 850 volt. Show that the final momentum, you should be able to do that. Right? Energy of electron, E times V. Right? E is 1.6 at 10 to the minus 19. And potential difference is 850. You get that? Right? They can calculate your kinetic energy. This is your AS work. Right? We write the equation to get P square over 2M, and P square equals to 2E over M, cross multiply. The momentum is just square root. Right? That's your 2E, you calculated, and then mass of electron, can anytime it will disappear. Calculate the de Broglie wavelength for this electron. That's all. Getting you to use the formula. Yep.
Yeah.
And then that describe the experiment.